Dear students, welcome to the lecture series on the topic Engineering Graphics. Today we are going to discuss about projections of the lines. I am Dr. IPS Ahuja, Professor, Department of Mechanical Engineering, Punjabi University, Patiala. Now here we are required to evaluate the orthographic projections of a line which happens to be inclined to the horizontal plane and parallel to the vertical plane. So here we have got the length of a top view of a line parallel to the vertical plane and inclined at 45 degree to the horizontal plane. It is equal to 50 millimeter. So here this apparent length has been given to us as 50 millimeter and the line happens to be parallel to the vertical plane and inclined to the horizontal plane at an angle of 45 degree, and we are also provided with the coordinate location of one of the ends of the line. So one end of the line, it is lying 10 millimeter above the horizontal plane and 25 millimeter in front of the vertical plane. So we are required to draw the projections of the line and evaluate its true length and also draw the right hand side view projection of this particular line. So let us proceed with the construction of the orthographic projections of this particular line. So since here we are required to draw the front view, the top view projection as well as the right hand side view projections. So the front view projections will be drawn onto the vertical plane above the XY reference line. Top view projection will be drawn onto the horizontal plane, or this will be drawn below the XY reference line, and the right hand side view projections will be drawn on the left hand side of the front view projections over here. Now here we have got this transfer line which we have drawn. That is, this transfer line will be required to transfer the distances of the points A and B from the vertical plane from the top view to the distances in the profile plane over here. That is, the distance of the point from the vertical plane in the top view will be transferred as the distance from the vertical plane in the profile plane projections over here. So let us proceed with the evaluation of the front view and the top view projections of the end A of the line. So we know that end A, it is lying 10 millimeter above the horizontal plane and 25 millimeter in front of the vertical plane. So let us mark this distance 10 millimeter above the XY reference line and 25 millimeter distance in front of the vertical plane, that is below the XY reference line. So point A dash, that is the front view projection of the point A onto the orthographic projection. So this will be drawn 10 millimeter above the XY reference line. Similarly, the top view projection of the end A of the line AB, this will be drawn 25 millimeter below the XY reference line. Now next, we have been provided with the information that the top view, so this is drawn parallel to the vertical plane and it measures 50 millimeter, right? So since this is a line which happens to be inclined to HP and parallel to VP, so the top view of this line, it will be measuring 50 millimeter and it will be drawn parallel to the XY reference line. So once we locate this distance of 50 millimeter, that is AB top view apparent length projection of this line. Now from the point B of this top view projection, we are going to draw a vertical projector line through the point B, and onto this vertical projector the front view projection of this line will be lying over here. And how do we obtain this point B dash over here? We have to mark an angle of 45 degree because we know that this line, it happens to be inclined at an angle of 45 degree with respect to the horizontal plane. So the moment we draw a projector line through A dash and extend it in such a way that it should be meeting the vertical projector line which is emerging from the point B. So this point of intersection of this projector line A dash B dash at an angle of 45 degree. So this A dash B dash front view projection line has been marked at an inclination of 45 degree with respect to the horizontal plane. And another thing we need to understand over here, since the top view projections, that is AB, corresponding to this line AB, this projection happens to be parallel to the vertical plane. Therefore, the projection of the line on the vertical plane, that is its front view, it is going to describe the true length of the line into the front view projections over here. So this way, whatever projection A dash B dash has been obtained onto the vertical plane, so these projections will reveal the true length of the line over here. Now, having obtained the front view projections of the line, the top view projections of the line, now we will proceed with the determination of the side view projections of this particular line AB. So we know that at whatever height point A dash is located, at the same height into the profile view projections over here, we are going to locate the location of the point A double dash. So the height, one coordinate corresponding to point A double dash has been defined into the profile view projection. Now we need to define of this point A from the vertical plane. It happens to be 25 millimeter as it has been represented over here in the top view projection. So this distance of 25 millimeter represented in the top view projection, it has to be transferred to the same distance in the profile view projection. So now, in order to transfer this distance of 25 millimeter in front of the vertical plane to the profile view projection, what we have to do? From the point A, we are going to draw a horizontal projector and extend this projector till it meets this transfer line at this particular point. So here we have been able to obtain a point on the transfer line corresponding to point A of the plan projection view. So once we obtain this particular point, now we can see that this distance of 25 millimeter from the vertical plane in the plan has been transferred to 25 millimeter distance in front of the vertical plane. So this is the vertical plane. So this distance will be 25 millimeter in front of the vertical plane, right? So the direction has been changed over here. So now from this point we will be drawing a vertical projector line and extend it up to the point where it is going to intersect with the horizontal locus line of the construction line which has been projected through the point A dash. So here we are going to locate point A double dash over here. Similarly, B double dash point has to be located in the profile view projections over here. So now from the point B dash, that is at whatever height this point B dash is located in the elevation, so there will be same height corresponding to the point B double dash in the profile view projections over here. So from B dash point in the front view, again we are going to construct a horizontal locus line and move into the profile plane such that the height of the point B double dash has been located over here. That is, one coordinate has been located, that is onto this locus line point B double dash is going to be located. Now in order to locate the distance of the point B from the vertical plane in the profile view, now we have to translate this distance. So what is this distance of point B from the vertical plane in the top view? This distance again happens to be 25 millimeter. Why? Because this plan projection view happens to be parallel to the vertical plane over here. So point B will be located at a distance of 25 millimeter from the vertical plane. So this is the representation of 25 millimeter in front of vertical plane in the top view. So in order to transfer this distance into the profile view projection plane, we will be drawing a horizontal locus line and extending it till it meets this particular transfer line, right? So wherever the intersection occurs, so we have been able to transfer this vertical distance into the horizontal distance over here, right? So this is the 25 millimeter horizontal distance. Now this is 25 millimeter in front of the vertical plane. So from this point, again a vertical projector line has been extended till this vertical projector line will be intersecting with the horizontal projection line which we had drawn earlier, extending from the point B dash of the elevation. So this intersection of these two projection lines will be providing us with the location of the point B double dash. A double dash had already been obtained. B double dash point has been obtained. Now we can join A double dash with B double dash over here. So this provides us with the apparent length representation of the line AB in the right hand side view projections, that is A double dash and B double dash. So this way we have been able to evaluate the front view true length projections of the line, the top view apparent length projections of the line, and the right hand side view apparent length projections of a line which is lying in the first quadrant and the line is inclined to the horizontal plane and parallel to the vertical plane. So this is all for today. So we'll be continuing with further discussion about few more illustrative cases of orthographic projections of the lines in the coming lectures. So thank you very much. Thanks a lot.